At different times and places in history, people believe the Earth to be a rectangle, a cube, something like a huge pancake, and even as pear-shaped. Here today, I submit that the Earth is something like an orange with a really thick skin. Our planet itself is the inside meat of the orange, and the skin itself is representative of a mysterious outer protective layer that shields us from harmful external influences. In fact, the role of this defender is performed by the Earth's magnetic field, or magnetosphere, an invisible armor enveloping our world. However, recently, frighteningly, this shell has become less and less reliable. According to scientists, there are ever more weak spots appearing in it. So what would happen if our planet loses this magnetic field entirely? The Earth's magnetic field was formed 4.2 billion years ago and now extends out 600,000 kilometers from the planet. Researchers agree that the secret of the manifestation of this amazing invisible buffer lies in the core of our planet. The core consists of a solid inner part and a liquid outer part. The rotation of the Earth creates friction between these two parts, and as a result, an electrostatic charge appears. According to the laws of electrodynamics, a magnetic field is formed around any moving charge. Our planet can be considered as one giant magnetic dipole. Remarkably, its south pole is in the north, and the northern one, respectively, is in the south. Also of interest, the geographic and magnetic poles differ slightly. The axis of the magnetic field is inclined with respect to the Earth's rotation axis by 11.6 degrees. But the difference isn't that significant, and thanks to this, we can use compasses. The arrow of a compass points exactly to the south magnetic pole, and with only a slight deviation to the northern geographic pole. None of the amazing range of magnetic forces can be seen with human eyes, but many other of the Earth's inhabitants recognize them easily. For example, for migratory birds, magnetic zones are reliable reference points that helps to keep them from getting lost during long-distance travel. These magnetic forces also serve as a kind of GPS for sea turtles and even cows, believe it or not. This unusual talent of our bovine companions was revealed by an analysis of satellite photos of 8,510 individual cows from 308 different regions from around the world. Nevertheless, we humans simply do not see, hear, or feel this force in any way that we know of. Still, however, unlike animals, we can enjoy the staggeringly beautiful sight of the aurora borealis, or northern lights, which is conjured when the magnetosphere is sufficiently disturbed by a solar wind. Our invisible magnetic shield keeps some of the ionized particles of the solar wind from penetrating beyond the upper atmosphere, redirecting the particles to the poles. At the poles, where some of the particles enter the atmosphere, they cause a glow as they interact with oxygen and nitrogen. The magnetic field of the Earth is really quite unique. No other planet in the solar system is clothed in such an incredibly powerful protective armor. Indeed, without the magnetosphere, life would have most likely been impossible due to the impact of hard radiation. On Mars and Venus, their magnetic shields are very small. Additionally, according to one theory, it was because of the unfettered influence of the solar wind that those planets lost most of their water. Unfortunately, it's quite possible that we, too, may soon lose our magnetospheric protection. The researchers behind this hypothesis report that at present, the intensity of the magnetosphere is decreasing at a rate 10 times faster than before. At this rate, in a mere 2,000 years, it could completely disappear. These results were confirmed by the latest measurements made by the innovative SWARM mission, a constellation of 3 satellites that the European Union sent up to study the Earth's magnetosphere. According to SWARM scientists, the catastrophe is due to the displacement of the Earth's magnetic poles, as well as an increase in solar storms that deplete our magnetic shield. But there's one more cause for this depletion that is a confounding mystery for geophysicists. Something mysterious is happening under Africa. An unknown force originating there is reducing the magnetic field over a vast area, from Chile all the way to Zimbabwe. In this enormous region, the magnetic shield is 3 times weaker than in almost all other areas. Scientists call this phenomenon the South Atlantic Anomaly. There's an assumption that this decrease in the magnetic field is somehow related to a particularly high density in the hot currents of magma between the mantle and the core. These currents are located at a depth of about 2,900 kilometers under the African continent. It may be that the anomaly developed this way as much as several tens of millions of years ago. However, there's no concrete proof supporting this theory. In any case, most scientists believe that this mysterious region's magnetic deficit in some way influences the reduction in intensity of the entire Earth's magnetosphere. And the strength of the magnetosphere is dropping so severely that quite soon it will flip entirely from one side of the planet to the other, with the poles switching places. It's quite frightening to imagine such an enormous, global, natural phenomenon taking place. What will be the consequences? However, experts reassure us our world will not perish overnight because of it. The Earth will not stop rotating. It will not jump out of its orbit, and the planet itself will not flip upside down. In fact, over the long history of our planet, the poles have changed places many times. This is confirmed by archaeomagnetic data obtained from analyzing ancient objects and prehistoric geological formations. Studies have shown that over the last 160 million years, magnetic north and south have changed places about 100 times. Traces of the most recent switch indicates this last happened about 780,000 years ago. However, the polarity has previously always changed quite slowly, over several thousands of years. And before this changing of poles, the magnetic field weakened over a long period before eventually heading to zero. This process, according to geophysicist Richard Holm of Liverpool University, could conceal a trap for humanity. Before inversion, our magnetic cover will stop protecting the Earth. Our planet for some time will be entirely defenseless against the hard radiation that comes with the solar winds. This will, among other things, provoke massive malfunctions in the operation of electrical systems. Strong fluxes of radiation will also interfere with the operation of artificial satellites in Earth's orbit. However, we humans won't have any time to try and save these artifacts of civilization. We'll be spending every second we have just trying to survive. Increased radiation will lead to a tremendous outbreak of cancer, especially skin cancer. Due to the radiation, many people on the planet will also experience other serious disorders, including numerous heart failures. Weak, terminally ill children will begin to be born, and the number of people remaining on the planet will gradually decline to just several thousand. Hard radiation can also cause serious mutations in animals. It's possible that most biological species will disappear forever from our world. According to one hypothesis, it was a pole change that caused the extinction of the dinosaurs. Additionally, unprecedented tectonic movements could begin, and the entire atmosphere could gradually leak out into space. However, not all scientists agree with this gloomy outlook. As evidence, Alexander Spiridonov, a senior research fellow at Moscow State University's Geological Department, cites an example from the past. 48,000 years ago, over South America and the South Atlantic, the magnetic field weakened to 4 to 5 times less powerful than it is now. At that point, everything seemed to indicate that an inversion would soon take place, but it never came to be. And after approximately 1,000 years, the field returned to its original configuration. As far as modern science is concerned, there were no ecological catastrophes during this period. So perhaps in our case, this invisible protection that is the Earth's magnetosphere will similarly weaken just a little more and then begin to strengthen again. In fact, we likely won't even notice these fluctuations. But in the worst-case scenario, the magnetic poles will change after all. However, according to the scientists, we won't have to pack suitcases and hide under the Earth or escape to other planets. It is yet to be proved that serious biospheric crises or natural disasters occur during the inversion period. But still, such a large-scale rearrangement will necessarily leave its mark on the planet. A strong solar wind, when interacting with the atmosphere, can lead to changes in its chemical composition and in other physical properties. And it's likely that this would affect the climate. Nevertheless, as with previous pole shifts, there will not be a global catastrophe, and radiation will not destroy all life on Earth. Perhaps some species of animals will disappear, but empty niches will soon be filled with more adaptable organisms. It should be remembered that it's thanks to mutations that life on Earth develops at all. It's part of the evolutionary process. And people, most likely, will find some way out of this situation. For example, by trying to create an artificial magnetic umbrella above the planet, scientists from the Planetary Division at NASA now propose to do something like this on Mars. For this, they propose constructing a machine with massive deflecting dipole magnets capable of creating a field of about the same strength as that of the Large Hadron Collider. Gradually, the field would form a kind of magnetic tail that would eventually cover the entire planet. And some researchers don't even see any significant factors that could affect the operation of electrical systems. Both orbital space stations and artificial satellites experience the same effect of the solar wind as in a weak magnetic field, yet these devices do not malfunction and cease operating. Not usually, anyway. Conversely, magnetic forces often interfere with electronics. If it is too often, we simply cover them with a protective shield. In addition, the weakening of the magnetic field, even insignificantly, could increase the oxygen content in the atmosphere. Recently, experimenters found that the magnetosphere actually accelerates oxygen ions through itself and chucks them into outer space. So, in the near future, one should not necessarily expect severe cataclysms associated with changes in the magnetosphere. It's actually we humans who do the most damage, devastating rare animal habitats, destroying forests, damaging the interior, and sometimes even contaminating the Earth with atomic radiation. This has been your pal Riddle. See you soon.